We are in geometry. We are on lesson 10-2. We're doing the measure of arcs and central angles. So I want to talk about the notation because I know that the notation in geometry is particularly tricky compared to an Algebra 1, an Algebra 2, or pre-calculus class. So when you see this, what does this mean? Angle of ABC. This is a geometric object. It's talking about some sort of it's talking about two rays that come out and make this angle. So it's talking about this object. But if I want to talk about how much that measure is, like how many degrees is that, you need a specific notation saying, okay, now let's talk about not the angle itself, but how much that angle is, the value of that angle. The way that we do that in math is we say the measure of angle ABC. So it's a slight distinction. If you see a little m in front, that means it's talking about a number as opposed to the actual geometric object. So to test you guys, if I'm talking about a minor arc length AC, this arc length right here, I don't want to talk about that actual geometric object. If I want to talk about its measure, how many degrees it is, how would you say that in notation? Eli, go for it. The M with AC and the arc over it. Exactly. So this is now talking about what number do I have there? And whenever you're comparing two different things, if I'm comparing objects, you use this symbol. This symbol means congruent, meaning objects are congruent. You can have a square congruent to another square, but you can't ever have a square congruent to 45 because 45 is a number and a square is a geometric object. So instead of using a congruent symbol, we would use an equal to symbol for numbers. This, again, I will write it down for notes. This symbol is called congruent. Congruent. And you can say that objects are congruent, but numbers are equal to each other. That's the difference in the notation there. Okay, so, and this is like one of those easy concepts that's brand new today. The difference between an arc measure and a central angle measure. So both of these are going to be in degrees, which it doesn't really make sense, right? It makes sense to us intuitively why we have an angle here that's measured in degrees because it's some amount of rotation. But why does it make sense for this distance between A and C to not be measured in inches, but rather to be measured in degrees? And it goes like really far back in human history on why we talk about that. But in general, the Earth is it's a round thing. If you think that the Earth is flat, you need to see me after class because I need to show you why you're wrong. The Earth is round, and we can measure the Earth in terms of a rotation of that Earth. And if you ever have stared at a map, you'll notice that they might have longitude and latitude as a fixed amount in terms of miles, but more often than not, it is in degrees. If you've ever done GPS coordinates, you'll notice that the weird notation they use has a degree symbol next to it because that's how the world works. You have some sort of rotation. So when I talk about the central angle measure and the arc measure, they are the same thing. So I will write here, they are the same. So for example, if I tell you that this angle right here happens to be, I'm just making up a number, 61 degrees, that means that this arc measure right up here is also 61 degrees because this central angle has an intersection with A and C, similar to this arc that has an intersection with A and C. 61 degrees applies to both of those. It's intuitive. It's not that hard. I'm going to stop talking about it. So these are two tricks that are going to help a lot on the homework today. The first trick is what happens when you have intersecting diameters. Whenever you see on a diagram a line that appears to be a line, I'll never do something tricky like this where I'll have a radius and I'll do like a 1 degree off measure and go like that. I'll never try to trick you to say, aha, that was actually not a diameter. You can't assume that. Let's assume that anything that looks like a diameter is indeed a diameter. If you have intersecting diameters, you have what are known as, do you guys know this vocab term? When these angles make an X, you remember from our past units, what is that called? Starts with a V. It's going to be vertical angles. These two angles are vertical angles, and vertical angles, are they supplementary? Are they complementary? Are they congruent? What are vertical angles? Do these angles look like they add up to 180? Do they look like they add up to 90? Or do they look like they're the same angle? Good guess, but they're not always that way because, again, I could squish this line and rotate it to be like this line right here. And then this angle and this angle no longer add up to 80 degrees. So what's the word I'm looking for? Vertical angles are congruent. Vertical angles are always congruent. So if this angle alpha and this angle beta are the same angle, if they are congruent angles, then this arc measure AD and this arc measure BC are also congruent. So now I want help from you guys to practice your notation. If I'm talking about an angle and this is talking about alpha and beta, do I say an equal to sign here, or do I do a congruent sign with a little tilde on the top of it? Are angles congruent or are angles equal to each other? What was that? So they're not equal to. Numbers can be equal to, but objects have to be congruent to. So I'm talking about a geometric object here. So this is going to be congruent. But now I have a little m in front of it. That's the only change to get from here to here. Now this is talking about a number. So Evan, now what is this symbol going to be? That one's an equal to because we're talking about numbers. All right, let's give this to someone else. This is saying the arc AD and arc BC, arc AD and arc BC, those two are what? Congruent. So we write the congruent statement, which is an equal to sign with a little wavy tilde on the top. But if I talk about the measure of those, then I change it to an equal to sign. Exactly. And that is one trick that you'll use whenever you have intersecting diameters. The other trick is when you have a single diameter and you're trying to figure out, well, how many degrees is this thing? How many degrees is a line? Someone shout it out. 180, because if you're pointing at this direction and I go on the same line, I've rotated 180 degrees. So you can say here in the notes that this angle right here is 180 degrees for the central angle, 180 degrees for a central angle, which means that if I'm talking about the arc length, this arc length ZW, it is also 180 degrees because I told you this before. The measure of an arc and the measure of the angle are the same thing, assuming that it's a central angle. If you do weird things like an inscribed angle where I have a point right here, a point right here, and a point right here, this angle is no longer 180 degrees. It has to go through the center to make that angle. All right, so nothing that I've said is too groundbreaking. I've talked about notation. I've talked about a few tricks. Let's see how to apply this to the math that I'm asking for today. So in the first example, I want to find the measure of our arc RS, that's SQ. So I'm going from R to S and then all the way to Q. I'm talking about this giant arc measure here. It's called a major arc. Well, the problem is I don't know this length. So everyone start thinking, how am I going to find that length? I need to find this entire arc length. The problem is I'm missing a piece. What would I do? Time to turn on the brains. Here we go. Warm them up. Eli's got an idea? Talk to us, Eli. That is a great idea. So we can add our own auxiliary line. It's a valid technique in geometry. However, we still don't know what that is. We know what that one is, and we know what that one is. That's kind of all we've got. So, another idea. Yeah, go for it. There it is. And that's the key fact. Because all angles around a point add up to 360, all of these arcs also add to 360. So if this arc QR is 140 and this arc RS is 94, this arc must be the missing number that adds to these two angles and adds to 360 degrees. So I'm going to go ahead and say that. I'm going to say 140 degrees. Let's go ahead and leave the units off for now. 140 plus 94 plus this arc, I'm going to call it QS. All of those add up to 360 degrees. And then from there, I just need to solve for this QS, that missing piece. So I need some help with my mental math. 140 and 94 adds up to, someone shout it out. 234, good. Plus arc QS is equal to 360. And then what am I going to do to both sides, Zane?
Subtract 234 on both sides.
Subtract 234 on both sides. Evan, you're going to give us the answer here. So that gets rid of the 234. I have arc QS is going to be equal to 126 is close. Is it the answer? No, it is exactly the answer. I apologize. It is exactly the answer. So it's the answer to one part of the question. The original question was asking, what is the measure, aka the number of the QSR? So or RSQ, sorry. So R to S to Q. We just found SQ. We need to add it to RS, and then we have our answer. So we can say that this one is going to be equal to 94 plus the answer that we just got, 126. Melly?
230.
It is in, I think it's 220. Like, think about it this way. If I put the 6 and bring it over here, this is now 100. So it's 100 plus 120. 220, yeah. So there's our final answer. It's just 220. All right, let's try another one. I'm trying to find a central angle. Notice this one is talking about an angle as opposed to an arc measure. I'm trying to find KMJ. So K goes to M, goes to J. This is what I'm trying to find. I'm going to go ahead and label that. Let's call it theta for now. I'm trying to find theta. How? I seem to be missing quite a bit of information. I only know that this arc measure is 110 degrees. Eli, you got it? It adds up to 180. Yes. Why? A diameter, yeah. A diameter always adds up to 180 degrees. So because this arc measure is the same as this central angle, we can label the central angle also 110 degrees. And we know that these two angles right here must add up to 180 degrees because it's a diameter, as Eli told us. So I can create a new equation that says 110 degrees, I'm going to leave off the units, plus theta should add up to 180 degrees. From there, we just subtract 110, subtract 110, and theta is equal to 70. Done and done. All right, let's try a slightly harder problem. In this case, the instructions have changed. For your homework, you will have 3 sets of instructions. One type is just saying, find this thing. Another type will be solve for X, and the other type will also be find this thing, but it has X's in it, and it has an additional step. So right now, we're just trying to solve for X. So I need someone other than Eli. Eli's been setting up a lot of the problems already. How would I set up a problem, hopefully an equation that I could set up so that I could solve for X? It's very similar to what Eli just did in number 2 using the diameter. You want to try it? Go for it, Zane.
Do you like try to get to 180 again?
Yeah.
So add them all up.
Yeah, so you're seeing that this diameter here adds up to 180. That means all of these arc lengths add up to 180. So I can add this angle, this angle, and this angle, and that should equal 180. Let's write it down. 62 plus X is the first angle, plus 50, which is the next angle, plus 70, which is the last angle, should add up to 180 degrees. And then I just solve. All right, Melly, can you go ahead and do a step? What do you want to do?
Add all of them up.
Add like terms?
Yeah.
All right, so we've got these 3 constants. Those constants add up to 142.
No.
I think it's a little bit bigger than that.
62. No, wait. 82.
There it is, 182. And then I have X, and that's equal to 180. I can do this next step for us, minus 182, minus 182. And then from there, X is equal to, -2. Is that possible? Can I have X to be a -2? Yes, but you can't have a negative angle. X can be anything you want as long as it makes a positive angle. Notice that if, I'm done, by the way, but if the question had said, what is this angle right here? I would have had to plug in -2 back in for X, and I would notice that this angle is 60 degrees, which makes sense because 6 plus 5 plus 7 adds up to 18 to get that 180. All right, time for the hardest type of problem where you have to first solve for X and then plug the X back in to find the measure of angle JHK. So J to H to K, I'm really trying to find this central angle right here. And in order to find that, I need to find what 5X plus 6 is. In order to find that, I need to know what X is. So our first step, we need to solve for X. I need to create an equation to solve for X, then plug it back in, and I'm done. Sorry, Eli, you've been participating a lot. You're our backup if I need a backup. I want someone else to practice setting up an equation. I have 3 people to choose from. Set up an equation that I could solve for x. Eli, you're going to confirm if they get a correct equation. They're going to look to you to see if they got it correct.
So that's add up to 180 again.
Again, we have a diameter, meaning that we have these 2 angles that can add up to 180. So make our equation, Evan.
12x plus 4 plus 5x plus 6 equals 180.
All right, Eli, did you get it? He gives them a thumbs up. All right, from there we solve. Let's give that to Zane. What do you want to do?
I'll just add
Yeah, combine like terms. What do you want to combine?
the x's.
Okay, so I have a 5x, I have a 12x that adds up to a
17x
17x. Combine the other like terms too. I have this plus 4 and this plus 6
plus 10.
plus 10. All right, that's still equal to 180. Melly, what do you want to do? Can you just solve the rest of it for us, Melly?
Minus 10.
That's going to give us what?
170.
170. And then finally,
Divided by 7.
divide by 17, and x is equal to 10. Should I box this? No, you're correct. Why?
It's not the answer for theta.
Yeah, I'm looking for theta. I'm looking for this measure of the angle JHK, this angle right here, and I haven't found that yet. All I found is that x. I need to solve for that entire thing. So let's go ahead and plug it back in. I have the original statement that says, or the expression 5x plus 6, and in that x goes this 10 from earlier, and I can simplify this. 5 times 10, everyone shouts out. 50. And 50 plus 6, Evan, is 56. So 56 degrees, I'll do units at the very end there, is the answer that we're looking for. So just to review, sometimes I can ask for a basic shape. I can either ask for an arc measure, or I can find some sort of angle measure. Sometimes I'm solving for x, and sometimes I'm finding an arc measure or an angle measure, but I need to solve for x before I do that. Those are the 3 types of problems that you'll be facing today. Cool. Everyone give me a quick fist of 5 on how you feel about today's lesson. Seen a 4, a 5, a 5, and a 5. All right, thanks.